if there's anybody who's going to present this in a really interesting way, it's going to be Luke Claus. He is, one of the gifts to explaining, to explainer kind of talks. He was a gift to us in social text 15 years before, and being able to explain cool stuff. And sure enough, it was not only interesting but fascinating in a way that I thought, boy, the Silicon Valley engineering leadership community is really going to be thrilled with a combination of understanding Lambdas for me for the first time, finally, as they've been clobbering me over the head for the last couple of years, but also taking a look at the history of deployment from on-prem servers to the current world, to throwing things out into Lambdas and giving a whole lot of different kind of responsibility to all of us. And with that, Luke, let me hand it off to you.
All right, so this is going to be a talk, Majestic, Monoliths, and Serverless Computing 2020 and beyond, AKA serverless for those of us with servers, okay? So before I get into this talk, this is kind of what I'd like to accomplish in the next hour. So like, what is a serverless even, right? Like, we've got some suspicions that it involves servers, even though it's called serverless. So that's like a good clue. I hope to impart like why you should care about this, why your team may want to care about this, and why you as a leader may want to care about it. And then I'm going to kind of demonstrate that by teaching you a little bit about Wardley mapping. And then I'm going to show specifically how, even as someone with like a traditional application architecture, kind of monolithic architecture, how Lambdas and serverless tech have really helped. I'm going to use terms Lambda. My system is mostly built on AWS and on Lambda, so I'm going to use that. But I'm not really talking too specific to AWS. You can take the same ideas and go to your other clouds and stuff like that. A little bit about my background first. I've been doing software for about 20 years now. I started in 2G, 3G kind of wireless soft switches, moved into kind of a enterprise software space, and then I ended up joining Social Text, and I started working remotely through a company in Palo Alto. Met Ron there, a lot of other really great people. And then in the past 8 to 9 years, I've become an entrepreneur and co-founder of Recollect, which is my company. And we're a communications platform for cities. We specialize in communicating with cities and residents, helping cities communicate about solid waste and recycling. So if there's a chance that any of you have ever got like a garbage day reminder to like take your garbage out from an app, there's a chance that I like coded that for you and invented that. So you're welcome. Secondly, a little bit about our infrastructure. It's not too exotic. It's basically, a mix of new and old technology over the past 10 years. It's amazing how much technology has evolved in this, even in the 2010 to now. Like when we started our company, Docker didn't exist. That was not even a thing. And that kind of evolved, and now everything's all containers and all sorts of stuff. So we basically have JavaScript apps and mobile apps that build on top of a REST API. We have EC2 servers that run our REST APIs and run our job queue, pretty kind of normal vanilla stuff. We've got our Postgres database. We're not like a microservices architecture, and I'm not going to try to convince you to do that. We do have a handful of smaller services that we've built up, and I think that's pretty common. So hopefully, like none of this, you should be being like, wow, that's really weird, Luke. Hopefully this should be like, yeah, that's pretty normal. So what is serverless? So I just want to highlight, there's confusion here because serverless is both a general term describing an architecture, and it's a specific tool set called serverless. So that can be kind of confusing. So I'll try to be specific about what I'm talking, but generally we're talking about serverless architectures. This tool set called serverless is also quite nice. And if you're just getting started with these technologies, I would probably start there. It's really easy to get Hello World apps up and running, and it takes care of a lot of the good management. So little plug on that. Okay, I'm gonna have a drink here. It's not vodka, that's the line you're supposed to say. Sorry, just trying to fit into the group here because I'm new. So what is AWS Lambda, or what is serverless? So I'm gonna first make the case that it is not a big deal, okay? It's basically CGI bin, people, right? You write some code, you zip it up, you upload it to the cloud, which is just other people's computers. Your code magically runs, And it's multi-language. You can upload your Perl scripts and your PHP and anything you want to your CGI bin, and it just works, right? There's no servers to manage, right? Like your ISP has your CGI bin directory or something like this, right? It's kind of simple in that way. It's not a big deal in that way. It's just running your code for you. There are servers involved. So like token Python, slide of Python code here. We got a Lambda handler. It gets an event. That event is going to be like whatever triggered our Lambda, whatever triggered our code to run in the first place, and some context about the environment it's running in. We can grab some parameters out of it, and then we return some data structure. This is like at its core, this is kind of a Lambda. It's not a big deal because you can trigger these Lambdas kind of like whenever you need. So, you know, in the old world of CGI bin, you'd trigger it just by a web request. Well, in Lambda serverless stuff, you can trigger things by web requests. So HTTP requests can come in and trigger your code. You could trigger your code on a timer, right? You could just have a clock that ticks, and every minute it triggers your code, and the event you get is like a time or something. It could happen when someone uploads a file to S3 or to your data bucket. It triggers your code, right? Or you could just trigger the code. You could just say, hey, run my Lambda, right? So I think that's kind of not a big deal. Okay, but on the other hand, this stuff is kind of a big deal, and I'm now going to make that case. So first off, with these kind of serverless technologies, as a developer, as a team, I can focus on my code and what I'm trying to accomplish instead of the whole deployment stack and managing my EC2 servers and making sure my Ubuntu is upgraded and all of this kind of stuff. I can just not worry about the OS that it's running on and just maybe move up the stack. I don't need to worry about security stuff. I can also easily deploy code in multiple languages. So as someone who has a team, and our team is like mostly skilled in certain languages, there are times when it's really helpful to be able to really quickly have execution environments where you can run other code for like certain, maybe that library is easier to use in that language.
For slight clarity, can you name like examples of how many languages are available, please? Just out of curiosity. Sorry, thank you.
Sure. So I can only kind of speak to AWS. I know in AWS, you've got Java, you got Python, you got Node.js, you got C#. I think they've now got it so you can kind of bootstrap in any of your own languages. So you can put in kind of any language you can build an executable for. And I'll have an example of that later on. And then secondly, it's kind of a big deal, again, because I'm only paying for what I use, right? And so there's trade-offs here, right? So for, you know, a lot of people are like, oh, if I just port my current application to go run over Lambda, it's going to be 3 times more expensive. And like, yeah, that may be the case. So it's like, you know, it might be more expensive just overall as a net load, but you know, you have this flexibility where you are only paying for what you use, and you can design and architect your systems in a more cost-effective way potentially. And then it's also kind of a big deal because a lot of the stuff that we know and we know how to do in our monolithic architectures, like scaling our monoliths and tuning our monoliths and monitoring them and logging them, all of these things are a little bit different in a serverless land, and they're going to be kind of a little bit unfamiliar to you if you're new to this stuff. And so you're going to need to figure those out. And so for that reason, I think it's kind of a big deal. And then I think the biggest thing that I think it's kind of a big deal, and I think this is more of a bit of a longer term trend and something that we as engineering leaders should think about. But when we have transparency into the financial aspects of our system, I don't know, I call this FinOps. I don't know what you can invent the name or someone can tell me what the name is. But, you know, we have, maybe I'll start on the left, right? In the old world, you bought servers and you racked them. And then before you did that, you had your engineer go say, hey, I need you to do performance tests because we got to buy systems and I need to know how big they're going to be for a big site launch in 7 months. And so then we would just say, oh, well, let's just buy it even bigger instead because maybe we'll be successful when you had all this capital outlay, right? Now, then we're kind of in this era of server rental where we've got EC2 servers or other kind of systems or even Heroku, and like all our code runs there. And now our costs and our compute, like, we just got our glob of EC2 servers, and that has a bill that you get at the end of the month for it, but you don't have that transparency. Where I think serverless is super interesting is you get per function billing. You get per 100 millisecond, per how much gigabytes of RAM it used billing. And so I just think it's super crazy because you can now ask questions like, is it cost effective to refactor this? Like, I know this code is terrible and slow, but it cost me $7.62 a month to run. So like, don't spend any more time on that developer. Or you may get some functions that start running and using a lot. And you're like, okay, well, now we have transparency into that specific system, that part of our code. And we could consider the financial implications. So I think for that reason, it's kind of a big deal. Okay, maybe you don't think serverless is totally the future yet, and that's totally okay. I'm gonna now teach you all some maps, some Wardley maps. So we're gonna take a little break from this topic of serverless. We're gonna look at maps, and then maps are gonna help us kind of explain where we've been and where we're going. Okay. I am now going to steal Simon Wardley's slide deck because his slides are better than mine and I didn't want to copy them all. So I'm going to just teach you a little bit of Simon Wardley's Wardley mapping and why this is cool. Okay. Wardley mapping is a communication technique. It's a mapping technique. We draw maps and then we can argue about them and agree about things and disagree about things and say, I should do this here or that there. Maps are really about situational awareness and understanding your systems, okay? You need to understand yourself before you can have strategy and acting out in the world. So there's maybe one or two of these examples. So in the olden days, this was Viking navigation, right? So from Hernam, you head due west towards Havarf, and then you will have, so I'm sorry, Tejo, maybe you could pronounce any of these words better than I am. I'm just gonna not do this well, but then you're going to get a glimpse of clear weather, but the south of the islands, that sea is to the right, and it's between the distant mountains, and this also south of Iceland. And so this is the story that the captains were told to navigate. And roughly speaking, on a map today, now that we have maps, it just looks like that. So the question is, so he got lost, and he kind of went down here, and then went all over here, and but eventually he found it. So if you have I'm just going to skip this and make my point. It's like, which would you rather choose in making strategy discussions? Would you rather choose the verbal story, or would you rather choose a map where you can argue and say, hey, I think this landmark is over there, okay? So kind of, and then which do we use to navigate our business so often as we tell each other stories and we read Hacker News articles that this company had success with serverless and their company switched to microservices and that was all great and that's why you should do it too. And this is kind of just meme copying. So his other example about mapping is about chess. Imagine you've only seen these characters and you play the game just by making random moves. And so I'm going to do this and he's going to do that. And then we're going to play a game and eventually someone wins. Okay. This is a terrible way to play. And over time, people are going to analyze this and they'll use machine learning to look at this. And then they'll write Harvard Business Review articles about the best techniques for this. And it's all based on this. And then one day someone will have this map of a chessboard. And the chessboard defines the boundaries, and it defines the movement, and it defines the rules of the game, and it provides you a visual. And so you are in your world, and you're playing with your kind of patterns, and they're looking at a chessboard, and then they beat you just super quick. You've lost. And you're like, what just happened, okay? So maybe this is cultural. We told ourselves great stories, but we lose because we have low situational awareness. So Wardley mapping is going to try to help improve our situational awareness. And again, which would you try to learn from? Storytelling, meme copying, secrets of success, or understanding the context in the gameplay? Okay, last one. This is a fun example, and let's go for it. So imagine you're an ancient Greek politician, and you have a problem, Themistocles, I guess, and you've got the Persians invading, and that's kind of a problem because you want to live. And you're like, well, we could defend here, or we could defend there. We got these different ideas. What should we do? And I think what ultimately happened is they're like, hey, let's force our opponents along a path through a very narrow corridor. I watched the movie 300, so this is all my knowledge about this. And then there's steep hills, and we force the Persians through there, and then we can use our superior strength, right? And we're going to block the ocean there. We're going to force it, and this is our strategy going into battle. Okay. So now we're the Greek army. It's the eve of battle. Themistocles is giving us our hey, we got to defend Greece against the Persians. And then he says, I don't have a map, but have no fear for you, for I have created a SWOT chart. And we're going to use this SWOT chart to figure out what to do for our strategy. Let's consider our strengths here. Okay, our strengths are that we have a well-trained army. We have a high level of motivation not to become slaves. Our weaknesses is that there's other people that might attack us, and the Persians, there's a lot of them, so it's definitely a weakness to our strategy. There are opportunities here, and there's some threats here. So let's just think about this, and we'll go around the room and generate ideas, right? This is what we do all the time. So what would you use to determine and communicate strategy in battle, right? Clearly, a map is better. So then Simon, who's the guy that invented Wardley mapping, he basically went on this journey and is like, well, what do other business leaders do? Like, surely as a CEO, like other CEOs have strategy and like they're doing stuff, and he didn't really find anything. Long story short, you know, we can, he makes the case, we can play strategy like chess, or we can tell each other stories like alchemy. So we've got these basic, you know, as leaders, we're navigating, we're learning, and we're making strategy. We can play by chess, which is visual, context specific, and position and movement. Or we can do storytelling, secrets of success, best practices on Hacker News, and magical thinking. So I'm going to skip through a bunch of these. We have strategy. So I'm going to now slip back here, and I'm going to show you a Wardley map. Okay. You can have me back for a special section just on Wardley mapping, and I'll go through all 291 of Simon's slides, and it'll be fun. But for now, we're going to stop a little bit there. This is what a map. So on the vertical axis, up and down, the very top, you have users. Okay, that's our anchor. We're anchored on users' needs. So in this case, we've got the business and we've got the public, and they want a cup of tea. Okay, so as you go down, you have this kind of chain of dependencies, right? So these are things that that are needed to fulfill the things above them, right? So this is a kind of a value chain. On the left to right axis, we have evolution. So on the very far left, you have this genesis phase. You have, you know, prototypes and things that are just barely created, and we're just learning about them. You then move into this custom-built phase of evolution, where you have, you know, I think there's actually some great slides here. Yes. So I'm going to actually just flip to this. This is going to talk a little bit about the evolution axis, which is the core of these maps and the core of my argument here about serverless. In the beginning, we had machines that look like this. This is the genesis, right, of machines. There's literally bugs in these machines. We have an application that needs to be run. I don't know, probably it's like bombing people in the military. And then we have compute. And then, you know, compute is totally like this genesis machine. Okay, so then time goes on. We invent mini computers, or I don't know. You people probably know what these terms are better than me. We've got these computers, and then these computers are now, we see this bottom compute thing. It's kind of like moving right along that evolution axis into a custom built. So now we've got our application. It's based on some operating system, and that operating system is based on a compute that I can now go and buy, but it's quite custom built. Okay, maybe I have to hire an engineering team to build that machine for me.
You're describing my dad's life.
We're gonna get to that. So then you have this kind of machine. And then, hey, there's that dude. And that dude now, he's got some best practices. Well, they're not best practices, they're novel practices. He thinks they're maybe going to become best practices one day, but today they're novel practices. And we've got this hardware that keeps getting a little bit better, but it still has a very high mean time to recovery. So when it messes up, you know, it takes a long time for us to get another computer in there to fix it, right? We've got our application, operating system, some novel practices that we're using. Both of these practices and pretty much everything in technology usually evolves to the right. Then we get into product rental. Then we get into things like Java get created. And so now our map for our simple application starts to look like this. We've now got best practices around coding, right? You've got, you know, you start getting into unit tests and the agile stuff and extreme programming that all came out. Earlier than that, we had object-oriented stuff. We've got kind of frameworks for building applications now that are still, maybe most companies have their own custom built framework, right? But now nobody's building their own operating system. Operating system, you just get, you know, whatever OS that you buy as a product. We've got really actually pretty good architectural practices. We know how to do these things. These machines are getting, you know, better and better every year. And then what happens? We get really good practices. We get really good coding practices. And then the cloud comes, right? So when the cloud comes, what the cloud is doing, and this is like, you know, Amazon EC2, right? Is it's evolving our compute. So it's taking us from servers that we used to rack in a data center, and it's giving us, or even like servers, yeah, actually this is probably best described as like, so the compute would just be servers. So it's like EC2, like product, sorry, I'm stumbling, let me pause. We're going from like, you know, even EC2 servers that you'd rent to just yeah, to just like where this is, computing is just a utility and you can really go anywhere with it. So then your CEO comes and says, hey, make my stuff cloudy. People are like, no, this cloud stuff, I don't know. Now it's 2010. Nobody thinks that the cloud is going to go away. But there was like 10 years ago, people were like, should you really be moving your data center to the cloud? And so what happens with the cloud is that you now have compute that's so cheap and it's so easy to just spin up another machine. So then we have to develop new architectural best practices, right? About how do we just handle having all of these machines? And so you end up with this like kind of coevolution. So this is a pattern you see a lot in mapping where things kind of evolve together. So our best practices are going to get better and then we're going to name them. And eventually we end up with this name DevOps. And so like to take a step back here, this world here where we have the hardware that has a high mean time to recovery, what's happening here is we tend to not want to have many systems, right? So in the in the old world, I'm going to switch back to my slides because I can speak better to them. So in 20 years ago, we're running our website. We've got like an online photo storage thing. We've got our own platform. It's like Ruby on Rails or something. It doesn't exist back then, but say you got your platform.net something. And then you've got your compute and your data center. And so what's really happening is like in this world where you're managing your own data centers, you do not want to have lots of servers. You want to have the minimum number of servers and they're expensive. You don't want to have to replace them often. So you tend to like scale up by buying heavier servers and beefier servers. What happened when we went to the cloud is that compute became a utility and we evolved new practices, which we call DevOps, which are basically like these people saying, hey, treat your servers like cattle instead of pets, right? Don't have these servers that you handcraft and they live around for years. Instead, have servers that are spun up using automation like Chef or Puppet or whatever. And then you spin them up and you get rid of them. And you can have tons of them and it doesn't matter. And if one fails, who cares? Spin up another one in a second. And a lot of people call this like totally crazy, right? And resisted it for a long time. And they said, hey, developers should manage the infrastructure instead of a special ops team that managed the data center in the past. And they built new practices such as infrastructure as code. And today in 2020, this does not seem crazy. So what I'm trying to build towards is that we have this best practice of DevOps that's now becoming kind of a good architectural practice, and it's now moving to become like a best practice. And as a result of that, we've been able to have more innovation on top of that, and that innovation is what you call like platform as a service, where we don't even need to manage those servers. They're so easy to spin up. We don't even need to think about the compute anymore. We just have the platform that runs our code. And what happens in mapping, we can talk about this more another time when we get deeper into mapping, but there's a lot of these patterns that you see. So what you see on here is whenever you have components that move to the right into this commodity phase, this tends to, commodity means standardization, everything is exactly the same, there's no differentiation. When you get to there, you tend to have new innovation that happen. I'm waving my hand up here to the left because I'm talking about up here. But it's like on the top left of that map, you've got new emerging things. You've got people building things that they couldn't build before because they have that thing, whatever the component was that went to there. So I think that while some of this might seem a little bit crazy to say, oh, well, I can't imagine my current app today totally running serverless, like that may be true, but this is where things are going. And I would say that unless you're like one of the companies, like a big infrastructure provider, or you're just a super detailed infrastructure provider, I'm going to say that things below that red line over time are going to come invisible to you. And I would not be investing my like capital in learning on like maximizing Kubernetes or something, because that's all going to be details below this. And I would try to be thinking on the stack above it. So I think it's still also early days. We still these like, I don't even know what to call FinDev or FinOps or something. Simon Wardley just calls it Jeff because that's just a name. But I think the case that I'm trying to make is that it's worthwhile to start building capacity around these practices. This stuff is not going away. This is not just a fad that's like, oh, serverless is the new cool thing and then it's going to go away. I'm trying to make the case that it's going to be here for a while. So, Tom, this is kind of getting to your granddad, your dad comment.
My dad.
Your dad. I meant to say your son's dad, but I've got the word granddad here, I saw. But hey, my son is 10, he's going to be 20 in 10 years. I'm going to be like, hey, well, he's going to be like, hey, Dad, I've got a new job. Did you ever have to run your own servers, or like, what's a server, And so I just want us to think about what skills should we start developing, and then what architectural choices in our product should we make that is going to ease this transition or help us be open to this transition.
I had one question, just exactly down that path, because one of the first things I ran into, and boy, this must have been a long time ago when cloud is going on, was my wife wanted me to develop for her an online recipe database. And I looked at Google, and Google, I think, is more down the Lambda path, which is you write it our way, we'll deal with it. And it was almost too foreign at the time when I actually, and that's
that would
also
be like App Engine or something?
Yeah, something like the way you have to write it in their code.
Yeah.
While I was more familiar, and then the AWS, God, this must have been like 2011, way a long time ago. But then I could spin up, servers in there. So that was more familiar. The question is, how to get these people? Now it's all familiar because I've been sticking with the technology. But perhaps sometimes these leaps are too far. Basically, and I can say exactly so you're going at the Lambda. I think it's wonderful, where you're just concentrating on the core of the code that needs to be executed. And you don't have to worry about the server, where it's all taken care of for you. But where is that? Sometimes do you think that there's a leap that's too far for people? You know what I mean?
Yeah, very much. I'm going to try to find a real quick slide to highlight this. Simon's got one here.
I'm also wondering about authentication and all the other stuff you need around that.
The security, yes,
Sure.
yes. Security is a big deal.
And that's to where this technology is a big deal, in the respect that those practices are going to be different than the practices that we've got on our server full architecture. To come back to the point, what we call the name for this in mapping language is inertia, and you draw it as a big black bar. And what often happens is it's often the case that you develop inertia between the product and commodity phases, because they actually have quite different profiles. And so it's often quite hard for any company to make the jump through those barriers. And so those barriers might be practices, or they might be just like, oh, we're so invested on this technology, it's hard for us to shift over to something else. Or it might be, this is part of our business model and it's too expensive. We don't want to lose this revenue, and so we can't do that inertia change.
It's funny you would say that, because I actually had a meeting with a bunch of people, and basically they were talking about they were so heavily invested in Windows. They're like, well, we're talking like, well, we need to move the Windows into the cloud. And I'm like, well, good luck,
Yeah.
So.
Yeah.
One analog that comes in mind that came up just like a week or two ago that I found really interesting, where you have like the established industry and a new player, and it was in space, in satellites. So SpaceX had this software engineer team ask me anything in Reddit, and one of the points that came up was that they said that part of the reliability is that you just have many satellites. So they are, even though the system, so the whole system needs to be resilient, but the established players might just make one massive satellite, and the new players, they just use COTS hardware and just make many of those. So it's kind of paradigm shift in that way. And this, just like a side story.
And to mention on the side story, I don't know if you know this, but AWS offers software. I mean, they basically in AWS, you have basically satellite tracking as a service now. You can actually go up there. I haven't even explored it yet, but you can actually get ground stations from AWS, which is just a completely paradigm shifting change as well. I don't know if anyone knew that.
Crazy.
Yeah, they rolled some demo out like last year.
So the way, just because we have time, I think I'll share this. So the way we would draw that is like the old rocket companies, they had a product that was here, right? And it was a product rental. And what SpaceX are trying to do is they said, hey, let's build our rockets over here as a commodity, so that payload lifting can be there. And once payload lifts become a commodity, we can do innovation up here. And so now they have their satellites or this new product that are here, and their strategy, and that strategy that you just said is, I'm pointing there because you're over there, but you're here. That strategy is only possible to do that once it becomes so cheap to be able to just launch up those satellites and not worry if one breaks, and have that resilience through a bunch of them.
Yeah, and yeah, just to add, it's not just SpaceX, but Starlink is there, the satellite system they're building, but
yeah.
same group of people.
Yeah. I could talk a lot more about maps, but I'm going to get to this, and then we can go back to maps if there's more questions. So yeah, there's like our tools, and then we've got development best practices, and we got best practice mixing software and financial skills, right? And then we've got our code execution environment where our code's running in production and fully scaled up and has all our concerns taken care of. Okay, so I'm going to now get into like 4 specific cases where our mostly traditional monolith-based architecture has found a lot of value from using Lambda technology. And so hopefully this section is going to just make it more real and hopefully make it seem also kind of like it's not a big deal. And then you'll get your sense there. So I'm going to just jump into these ones. So the first, and I think like from my talking with other CTOs is that I think these are like some general patterns that are not really specific to our company. So offloading work from an app. Okay, so basically as our app scaled, we had some parts that became bottlenecks. You look at your API endpoints, some of your API endpoints are slow. Usually when an API endpoint is slow, you look at different techniques to optimize that API endpoint. Like maybe we can put an index on the database, or maybe we can cache the data or do something like this, right? In particular, 2 endpoints for us were challenging: PDF generation and image resize, okay? So in the old style, in our old traditional architecture, we handled it just like any other API request to our backend. The challenges with PDF generation is that may take 3 or 4 seconds, how we were doing it using some open source module. And then if you made that API request into our backend, like obviously we've got real concurrency issues if anybody hammers on that. So this is kind of like a security risk to our system. If we need to scale that up, we need to scale up the overall capacity of all of our systems, right? All of our EC2 servers. In the new style, what we did is we built a small Node.js Lambda, Golang Lambda. It's its own little small code base. It's got its own unit tests. It's a small like little app. It upload it to Lambda. Lambda takes care of running it. It basically scales to infinity, whatever we want it to be. Basically has the same performance, still takes about 3 seconds. Still using the same technology under the hood, but we have no longer have the risk of all of these requests and the load of all of these requests coming into our system. So basically overnight in deploying the system, we just stopped worrying about scaling and concurrency of that component, of that subsystem. And then what's super cool, again, to get back to the financial aspect, is the costs are directly quantifiable and marginal, I would add. This is the biggest, we kind of have a little bit of periodic usage to this function. And I think on our biggest month, we did 166,000 executions of this, rounding up to be like kind of the most memory and assuming they were all 4 seconds. And that cost us a whopping $25 a month. And so I compare that cost to solving the same problem with our traditional architecture would have been scaling up and adding more EC2 servers at a much greater cost. Instead, we basically have shed work off of our core systems, and we can be more resourceful with those. And then it's like, frankly, was quite a small development project to build it, and it's kind of just runs on its own, set it and forget it. And all our regular deploys of our main app don't affect that component, right? This is kind of like microservices, but we're not doing microservices.
Do you really think set it and forget it is really? I mean, I understand. I'm just saying. Yeah. I mean, there's still going to have to somebody has to make sure things are operating. The new code, small and easy test. So you're saying that the testing is good enough that, and the actual core thing you're trying to solve is so small that it's easy to get through the testing, and that once it's
yeah. So what I'm saying is, we're going from like a component bolted on to our main monolith to a standalone small simple code base.
Yeah.
And when you tend to build small simple code bases and you do it fresh, you tend to write good unit tests, and you tend to so we have done the practice of building this small Golang code base out, having extensive unit tests for the functionality we need. And then the point that I'm trying to make here is just that you kind of upload it and you kind of forget about it unless you need to go add features. The challenge here is that if you forget about it, this is really not good, because at some point down the line, AWS is going to deprecate the version of Node or the version of Golang you're using or something, and you're going to need to do it. So I'm going to kind of come back to that as some best practices that you need to be thinking about, because there are risks that you just build it and then you do it, and then the guy who built it leaves, and then nobody knows how this component ran or how to deploy it. That's super legit. Another, maybe I could pause there. Any other kind of questions on this like offloading work type of flow?
Well, you've chosen an example, the generation of PDF. I'm going to call that at the periphery of some workflow. It's typically a PDF sent to some destination.
Mm-hmm.
I'm more curious about some block that's right in the middle of something, a block that would talk to 5 destinations or receive from 3 things and output to 4 things and so on. It's something that has right in the middle, and that's
sure.
That always takes
Let's
work.
get through the other examples, and then we'll see if I've hit one of those. I think I will. But I agree. And again, I'm laying out some use cases for Lambda that are beneficial for those of us with monoliths with big applications where we can't really imagine how to take our big application and make it all serverless. Or maybe that's not even a good idea to do. Any other questions?
Well, I see Paul asked a question, and I see it says, what is your experience with scaling serverless with complex systems with huge amounts of data? That's actually in the chat. I want to make sure Paul that got out there.
Yeah, so I kind of want to loop back to that one at the end. I don't have direct experience doing huge amounts of data processing on Lambda. I have ideas of how I might approach those problems, and I can maybe speak to those at the end. Probably Lambda is not the right answer, but maybe other serverless technologies or platform as a service type things. Okay, I'm going to jump into this next example. So we've got, this is like quite a simple example. We have a little app, and we got a sorting game, so residents can like learn the proper recycling rules for their community. We basically wanted to map URLs into an S3 bucket. Turns out you can easily embed your computing right at the edge of your CDN using CloudFront and this thing called Lambda at Edge. At the end of the day, we wrote this little Node.js program. This is just some error handling and comments eliminated. But basically what this is doing is, at a very lightweight way, just kind of rewriting some URLs and doing some checks. And this was, the reason I kind of highlight this is because if we had ruled out Lambda as like not one of the solutions that we could use, or we didn't say we had to build this on our traditional architecture, it would have been a lot more work and a lot more infrastructure to worry about. We would have had to touch our HA proxy and our Nginx. And so again, because this was a very small and like isolated outside of our core app, it was very easy to do. Costs were totally negligible, basically nothing. And it was like took kind of an afternoon to do that. This next one is, I think, like a really good use case, and I think something where it highlights the event-driven nature that serverless systems tend to have. So, in our system, we have customers that upload files to S3 buckets, and then we need to process them. And so, a traditional architecture, what you tend to do is you pull, or you have a cron job that runs and does scheduled updates at a certain time. We wanted to make this more real time. With Lambda, with serverless tech, again, it's super, super easy to do this. So in our old style, just want to kind of contrast different solutions here. So in our old style, you had a cron job that ran some code, checks files in S3. It's got to maintain state about what's changed, and then it blindly runs every time and re-imports. And so then with the new style that we went to, we basically wrote a little Lambda trigger. It's not even 100 lines of code. And basically, it just gets called. You can just a couple clicks hook it up, or you can use code as configuration, or infrastructure as code as infrastructure, to deploy that. And then basically that just gives us a real-time way where we can hook in our code, and then we can even leverage our monolith. So there's times where we use the Lambda really just as like a glue component to call into our system with the right credentials, and then say, hey, this is an action that needs to happen. Go do your processing in the monolith. I want to touch really quick on the serverless, like the serverless as a specific technology, not serverless as the general architecture, and just give you a sense of what that looks like. So if you were to go do the serverless Hello World project, you would do something like this. You've got a YAML file, kind of defines what your service is called. Oops. We've got some providers. I use AWS. We do Node.js 10, run it on some data center, and then we just define our functions. And so this is just referring to some, Node.js code, and then you define the events that trigger it. So a certain bucket, the Recollect data bucket. Anytime an object is created, and then we can specify prefixes that we want to ignore or whatever. So again, this just made it really, really like low code to add in some new functionality. And then the serverless.yaml way in the serverless technology, serverless.com tool set of running it has been really, really easy for our team to kind of quickly deploy these things in a scalable way. Okay, this next one is maybe an example that gets more into deep of the core of our system. Okay. The background here, the context, is that our system forwards requests into lots of other systems. Okay, so we've got lots of other ticketing systems that we forward into. You might have similar problems in your product. The challenge is that like all of those other systems are different and basically require unique code, right? Sometimes you're using a library, sometimes you're hand rolling your own HTTP libraries to connect or whatever. And so as we did this over the years, we were just adding more and more code into our backend APIs and needing to pull in this. And then some customer only had a SOAP API, and now we got to pull this in. And our monolith is just getting bigger and bigger, and it's just gross, right? It also means that like if I want to have a developer go build one of these, they need to know so much of our overall system before they could build this integration. So I'm thinking to myself, how can I just lower the cost to build those integrations and also reduce just the bloat of our monolith? I don't want it to keep getting bigger and bigger. So thinking about these problems, I'm also like, oh, some of these integrations would be much easier to write in other languages. So for instance, we don't use Node on our monolith on our backend, but Freshdesk, we needed to integrate with them. They had a really great Node.js library that took our integration and just dropped it down to like 7 lines or something. And I'm like, oh, damn, if I could just integrate using Node.js for this one library, that would be way easier. But how do I interoperate? How do I I don't want to have to maintain this execution environment for other languages. And so these integrations basically differ in kind of 2 ways. One is how do we map our data to their system? And then 2, how do we deliver that data into their system? And that may fail, we may need to retry it. And I didn't like the fact that minor changes to those integrations that a customer might need required a full deploy of our overall system. Like I get it, sometimes this, but it kind of sucks. And if I'm going to add another 5 or 10 integrations over the next couple of years, does that mean my whole app is just going to keep getting bigger and bigger? Is that the direction I'm headed? So I ended up using another AWS tool called Step Functions. Step functions you can think of as state machines as a service. State machines where every step is a Lambda. It could be the same Lambda, it could be different Lambdas. So what we have here is in the middle, we've got this big JSON document. And this JSON document is describing the states of my state machine. You see the top one there is called prepare request. It defines the Lambda function that would execute, and then the kind of arguments that it would get. It defines how to retry that state machine. And so I can kind of flesh out this model of how I want this state machine to operate. When I start a state machine, I'm going to just give it a JSON blob of my data. And at every step, that JSON blob gets passed around. And you can pass around parts of it or only modify parts of it. And each step can return parts of it, and you can put those together. So what we ended up doing was we realized that, hey, out of this state machine that we need to do for any time we forward a ticket, the 2 parts that differ for every implementation are the preparing the request and sending a request. And then forwarding, telling our system that it's done, and the error handling, that's all the same. So now what we have is we have each integration, like I mentioned an integration with Freshdesk. We have an integration, it defines 2 Lambda functions. One's called prepare request, one's called send request. The prepare request Lambda is super easy. All it does is map a hash from our hash into what the customer or what that other system would expect and do any kind of translation. And then the send request function is pretty easy as well. It just gets an input hash that's the formatted ticket, and it worries about sending it and doing error handling. And so this allowed us to basically implement each of our different integrations in the language that made most sense to do it. Now, naturally, that depends on the skills of our team and the other people we're working with.
There was a question online from John in Monterey. It says, how does serverless compare with PaaS, platform as a service type stuff, e.g. AWS Lambda versus Google App Engine, etc.?
I think it's the same thing. You're not managing servers. So, App Engine was early serverless. Heroku is platform as a service. I'm not here to convince you that you should use AWS platform or other platforms. You should pick the tools that are right for your team. I'm trying to just share, we are on AWS and we've used a lot of these serverlesses in this kind of like outsourcing of the work way. So what happens when a ticket comes into our system? It comes in via our API. We put together a JSON hash that describes that and all the information necessary. If there's other images that are needed or whatever, it might have links to those in S3 or where you could find all that information. We kick it up to the state machine and we say, hey, go run. It takes care, it might take an hour for retries and get it all done. And then it'll eventually, on that forwarded step, come back, call into our API and tell us that it's done.
You actually started winning me over when you mentioned state machines. I loved writing state machines.
So, with this new style, each integration has a simple, separate implementation. I could even go hire a contractor to build one of these integrations because you don't need to know anything about my system. You just need to know you're going to get this hash and you need to do that action. Each of those functions are very simple and easy. So it's like a nice way of componentizing the code, breaking it down. And then it's been good and cost effective. So I'll recap and then we can talk about some questions. So, I think there's two things to keep in mind. It's not a big deal. Like, I don't think it requires a huge investment. You don't need to move your whole architecture to serverless. And I don't think if you're new to serverless, that's a good idea. But you probably should be getting your toes wet. I think simple things are quite simple. And I think also it's very early days. So if you have very data intensive situations or processing that you need to do, probably AWS Lambda is not the right solution, right? Because it's got like a 15-minute maximum time. Maybe you should look at other serverless technologies like App Engine or like the Amazon ECS, Elastic Container Service, where you can kind of spin up containers that have a longer lifetime that can have the data closer to them. I will say that Amazon just launched a feature, I got it in my feed this week, where you can now mount volumes, big volumes to your Lambdas. So your Lambdas can now have a shared kind of disk that they can have access to. So you could bring that data to your Lambda, and then you could share that same volume with your EC2 containers or your Elastic containers. So I think that's pretty simple. Simple things are simple, and I think it's easy to get started. And I think there's a lot of opportunities to get started on non-mission critical things, right? There might be parts of your system, maybe a Slack chatbot that you've always been wanting to build. Try to build that into serverless technology just so you start to understand it, because then you're going to understand the things that are a big deal, right? So I think it's a big deal because I think this is where things are headed, right? And it's going to introduce this financial component into our jobs as a developer.
Oh, big time.
And I think this is like an emergent set of practices. So I'm not claiming that like, hey, you can go do serverless and there's just like tons of articles of just how you do it and you can copy their success. It's still in the days where you're needing to figure out the best practices, the good practices, the emergent practices before they become good and best.
So actually, we had a couple questions right here, if you don't mind.
Sure.
Is there any concerns about backup plans to avoid vendor locking, especially if using a vendor-specific capability? That's actually a very good one. So what you're describing, you're locked into AWS.
Yeah, definitely. Yeah, that is my opinion. I think there's much more upside for us to lock into AWS and maximize the advantages we can in those services and have a smaller team.
Well, how rich do you want Jeff Bezos to be?
Then I think this is better than it is to try to not take advantage of any of those technologies and try to build agnostic of them. To me, for my size team, that does not make sense. I have a buddy that works at PagerDuty. PagerDuty needs to be up all the time. If AWS goes down, they need to be up on another system. I get that. I just think most applications, that's probably not your concern. So I'm all for vendor lock-in. I think you've got bigger problems. That's my opinion.
Okay, the second question is it possible or practical to have an offline development experience with this?
Yeah, great question. So when I develop a little Lambda, like any of the ones that I've demonstrated before, that serverless framework, I'll show you, serverless.com, makes it super easy to test offline. So basically, you've got a serverless command line tool and you just say serverless invoke local, and it'll spin up your Lambda code on your Mac in a Lambda environment that you can test your code. You can pass in the event that you want and make sure that, so you can write a lot of tests using that. The other thing is, Lambda is not some special thing. You can still just write your code and write your unit tests and have a proper development process where you're writing tests on your code. Just because you're doing Lambda doesn't mean you don't have to do all of those practices, right?
All you're doing is you're developing the code elsewhere, and then when you think it's ready, you're just deploying it in there. It's executing it for you.
Yep.
That's it.
Yep.
Okay. One more question was from Maria. What workload and data migration? What about workload and data migration when wanting to change providers? Any insight on that?
No, I don't know. I was at a CTO meetup and a guy said, "Oh, but if you get tied to one vendor, they're going to give you all these credits to switch, and then you can get free credits." And I'm just like thinking to myself, like, how much time are you spending? Like, why don't you build your company rather than focus on chasing free credits?
And down your point, you might as well be giving people away free mobile phones just to switch servers, right? No, that's the same kind of thing. They don't want you to have the phone. They don't care about the phone. They just care about the subscription cost. So it's a bait and switch. It's a bait. It's a bait. I think is what you're saying, right?
Yeah. So, make sure you pick a good platform, I guess, is what I'm saying.
Longer lock-in. It's very interesting because what you're describing here is, a longer lock-in to something versus, Okay,
Yep.
Sorry. Your turn. Sorry.
That's okay. It's all good. Couple things just to kind of close on of like what I think about, what I think other leaders should be thinking about. So find small projects that your team can start just peripherally getting aware of these technologies, right? Start learning and thinking about what parts of your system would and wouldn't be appropriate for serverless today. I think if you're not aware of any of these technologies, you might not be aware of easy ways to solve problems. And that, just a heads up, you're going to need to learn new emergent practices about topics like debugging, logging, monitoring, right? All of those things still are important. They don't just magically go away because someone else is running your code. You're going to need to think about them, and then the solutions are going to be a little bit different than what you're comfortable with. Maybe you're comfortable with your ELK stack that you've been managing and hosting all yourself, and in a Lambda, that's probably not going to work as well. Maybe it will. I don't know. You could try it, but it's going to really depend on your context.
And it's also, you're talking about a division of how you're doing your job in general. Something monolithic thing, you're taking what you're doing and slicing it up into small pieces and having this piece execute like this and then like that, and then they hit it. One question I had is, how many URLs does this take? I guess it's a really funny question. Like, you've got all these little pieces of code. How does it get directed? Multiple URLs? How's it being directed, if that makes sense?
Yeah. So, in the examples I showed, 2 of them were triggered by URLs, right? So edge routing is clearly triggered by a URL. So that's got some, game.recollect.net or recycle.game. And then for offloading the PDFs, that's clearly triggered by a URL. For the other ones, there's no URL for those, right? Because that code runs when S3 changes. So that just happens magically.
Something behind the scenes. That's actually a back office operation.
Yeah. And then for the last one, for the kind of state machine, that's something where there's no URL, but our code is directly going to AWS and say, hey, spin up this state machine and go run those Lambdas to get the job done.
Okay.
There's a lot more to serverless than just Lambda. I know in this talk, I'm talking about Lambda specifically as kind of the highlight to explain serverless. But serverless is really just anytime you're not managing the OS, you're not managing the systems, you can kind of just say, hey, code go run, whether that's a zip file or whether that's a container, but you're saying, hey, just go run this.
And so another question is, will you share your experience with monitoring and security?
Yeah. Yes, exactly. So it's like debugging. How do you debug a Lambda once it's in production now? Logging. How do you find what it did a week ago? How do we know that it's still working? These are all questions that we hopefully are all answering today with our apps, and we have some competence in answering. And we're going to need to learn new ways of doing that, right? So I could speak to my experience, like with debugging is like lots of logging. And then for our logging, we use the CloudWatch logging, but we've had to build new practices about how to access those logs, how to search them, how do we have those CloudWatch logs feed into our other centralized logging solution, setting up that infrastructure, right? That's kind of like part of the big deal. For monitoring, that's kind of the same, honestly. We try to monitor health endpoints or other kind of health aspects of the system to make sure it's working. And then the maintenance is like a really good one. And this kind of comes back to the point you made earlier, which is some of these systems, you kind of set it and forget it. And if you do too good of a job, you're just going to totally like forget what you did. So when you're building these systems, just like you build any systems, serverful or serverless, you need to document your systems, right? So there's a really good book. I have it in my closet. The Susan Fowler book on.
You're supposed to say I have it on my bedside, not my closet.
Yeah, no.
Sorry.
Sorry. It's I know. I'm sorry. As a Canadian, I'm sorry. It's the microservices book by Susan Fowler, and she has an amazing checklist in the back that I think is really applicable, not even to serverless systems, but to serverful systems. But just talks about documenting how do you edit the code, how do you run the tests, how do you do a deploy, automating a bunch of that if possible into your CI system. So all of those practices are still important. They're just a little different, right? But it's very important that you document that, because some of those systems will work so well that you just don't think about them because you have other problems in life. And then AWS is going to send you an email to say, hey, Node.js 8 is deprecated. You need to upgrade it. And then you're going to be like, oh, shit, where does that code even live? And you're going to need to update it. So I'm kind of saying is set it and forget it, but don't forget it, because you need to write things down.
Right.
And then I think that there's big financial implications about all of this. Should I refactor this code if it's only going to save us $8, but it's going to take me 5 hours to refactor it? Probably not. That's probably a terrible idea unless there's other criteria. But is this Lambda now costing me like $700 a month? Oh, that's pretty interesting. Let's allocate 6 developer hours or something to go see if we can optimize that or to learn more about the problem. And I think this is super fascinating and not something that we've really incorporated before. I'm going to share the slide deck. There are a bunch of questions from last time I gave this talk that we'll go over that. So I'll share the link to this, and maybe there's some other questions in there, but I'm happy to hang out and talk. But thank you.
No, I want to thank you as somebody who basically got tired of hearing about serverless stuff, but this is actually a very good explanation about not only that, but how to you have to refactor how you think about code, how things are executed depending on your project. That this might be a way to go, to be, instead of spinning up something, having something idle, it'll just spin up automatically and go away. And one of the examples I had, but I mentioned recently for my team, was I had to test a WebSockets app, and they couldn't figure out how to get a server onto the internet. And I basically said, "Why are you wasting your time? Why aren't you just spinning up something AWS, using it when you need it, and it go away?" And this is almost a step down that further direction, where in this case, instead of being the back end communications, it was more like, you just need this as long as then it'll go away. As soon as it gets a request, it'll spin up, take care of it, spin out, and go away. So this is another factor of the same kind of thing like that. So this is very good, Luke. Said the rabbit. Not a real thing's working. Okay, another question. Do you want me to read these to you there, Luke?
Sure. Yeah, I mean, I have kind of been in the zone and sweating as my room is slowly heated up. So I'm going to step off camera and remove my sweater.
You're in Canada. It's not hot in Canada.
I know.
Oh, God. Okay, can you hear me?
Yep.
It says, if you run your infrastructure as code, it may document itself to an extent. Do you have any comments on that?
Yeah, I mean, that's like saying, you're saying, hey, this YAML file is my documentation. If I was a manager, I would be like, can you please also write documentation about how to run it? So I think you're right. Like, I think maybe the point you're making is like, there's different ways that you could implement your serverless. You could go and click in the console and like set everything up by hand, and that's okay. Or you could use infrastructure as code and write your YAML file and deploy it and check in your YAML file and have your team have processes around going and doing that. And I think that's clearly a more mature practice to do. Do you always need to do that? I don't know.
No, I mean, I think to step back to something you mentioned before is that somebody leaves and you don't know what the hell they're doing. Excuse my language. So basically, you need to be able to back up and be able to make changes. I mean, some of the complaints I heard today at my job was about basically they're running the problems where they have some stuff implemented in Java 8, and now all of a sudden they're trying to run on Java 11. It's not working, blah, 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 if you get the general idea. And so that's what's going to happen when you talked about what happens if you also knew Node.js, that version changes and basically it gets deprecated. So it's important to have this stuff documented, and very, very important. Documentation is almost important, and perhaps even outside the code, or at least in a place where everyone knows to look. It's the most important thing is saying, this is documented here. I don't care how you do it, but everyone knows, go look here for that. As a manager, it's more like where to go looking more than knowing what the answer is. That's always been my thing.
Yeah. Maybe I'll make this super real, and I'll say PDF. I'll show you what our internal documentation of this PDF subsystem looks like. So this is, you know, our team's documentation about the system that was created. Sorry, that's so small. Ron, I can see you leaning in there. So,
Yeah.
so we got some background, you know, build versus buy, a little discussion on that. We got a diagram of our architecture, you know, something like this, stuff going on there. We want to just kind of explain overall, how does it work? You can see we've got a Lambda generate PDF in there. We've got our GitHub repo, you know, stuff, how to debug it. Here's some things to check. Here's some health things to go check. I actually just got rid of that system, so.
Okay, we got another question. So are you done? Sorry,
Yep.
sorry. Yeah. Okay, so a couple more now. Okay, good. So any comments on using GPUs? At present, we take 5 minutes to spin up a VM with GPUs to perform 30 hours of AI-related tasks. Will this work with serverless? Any comments on that?
I mean, I don't see, you know, I don't see why not. I think it's just like, what is the serverless provider you're using that's going to provide that, right? So I don't know all of the serverless providers. Lambda is not the only thing that is serverless, I think is a key thing. And within AWS, there's like a whole family of serverless technologies. So one of them is Elastic Container Search Service, ECS, they call it. And so this is a place where you have your Docker container and you can say, hey, go run this container, and you don't have to manage the servers. This is AWS Fargate.
Yeah, yeah.
So I would check that out, and then you can choose, you know, you can, yeah, I don't know if you can get Fargate containers that have crazy easy GPUs.
Okay.
What I would say though is, again, we're like in 2020, and I think this is quite a long journey to get rid of all of these servers that we've accumulated. I don't think it's going to happen overnight, and I don't think that all the infrastructure that we need to do all this computing on serverless tech is here today. So I'm not trying to make that claim that all your workloads can happen on serverless today.
This is very targeted to a certain type of work and everything like that. So yeah, no, I agree with you on that. Okay, so an older one. Documentation is normally one of those processes that is challenging, especially business continuity planning around. Yes, very true. Are there any automation process tools you can recommend to help ease this pain? And that was my mailman delivering my mail.
Maria, I don't know that I have suggestions here. I don't think we're super sophisticated in what we do. I try to make sure it happens, that we write it. We use a wiki.
Well, I mean, but I think what you're describing is you're basically taking the business process and dividing it up in a different way. And so all these things are very small processes. Actually, that's one of the questions I had is, in all your experiences, what's like the shortest piece of code you have out there in Lambda? What's the longest piece of code you have out there in Lambda?
I think probably that Golang project was like the longest or the biggest, the most line of code. And then, but it compiles down to a binary. And then the shortest one would be that like routing example that was like 50 lines of code or something, and it runs at the edge to do, you know, just some kind of routing and keep that component small and simple.
Okay. So there's some articles coming up here about basically supplementary articles that put out there. I don't know if I'm missing, if I'm missing another question. Oh, if you, yeah. So basically, Taylor, it's the same kind of thing, kind of the same thing that Maria's saying. If you run your, no, we did that one, sorry. GPUs.
Authentication.
Authentication, yeah.
Mm-hmm. So there's a number of different ways you can do authentication. Like, I think you're probably getting at authentication in the context of a web request. So it might be the case that if you wanted to implement stuff on Lambda, you would implement that differently than you might implement it in your monolith. So on Lambda, you probably wouldn't have sessions, and instead you'd probably go with like a JOT or something like that. And then,
JOT, for the people who don't know JOT, can you describe JOT, please? Sorry, I apologize.
Yeah, so a JWT would be a JSON web token. And so that's kind of like an opaque, really long string of letters. And it is, you can validate it. You can kind of like introspect, look into it and figure out what it is and validate that it's really a valid token. So when you use Lambda, like for anything on the web, I think I had a slide about this. Maybe not. When you use Lambda, like you never hook up Lambda directly to the web. I'm talking about AWS Lambda specifically, right? Whenever you want to hook up to the web, you need this intermediary thing called the API Gateway, AWS API Gateway. And what it is kind of like a domain name. And then you can tell it, hey, I want to mount these paths onto it, and these paths go to my Lambda, right? You could put a wildcard and everything goes to my Lambda. And so in that API gateway, you can also define API authorizers, which would be separate Lambda codes, which would only do authorization and accept or reject the request. So you can basically write a Lambda that just does authorization, and then you could have several other Lambdas that are all through the API gateway, and they all reuse that same code. So that's like, I think the serverless way to do it, is to use a JOT, a JWT, and then to have less like session-based authentication. That's again where like practices change, right? And people need to find new ways to do it.
Okay, another question. What's the overhead for startup overhead for Lambda? Is it first call n seconds, following m seconds, milliseconds, except with JVM? The overhead, can you describe some of that?
Sure. So for our applications, we're kind of like user-facing. We have never had any concerns with the latency. I think if your Lambda is totally cold, it'll take a little bit to spin up. If that is a super critical aspect to the thing that is like preventing you from going to Lambda, you can pay them to keep your Lambdas warm.
Oh, they'll gladly take your money to go faster.
They will take your money and they will just keep your Lambdas warm. And I will tell you, I looked into it, it is not cheap. But it can be done. So if that is like the most important thing to you, then that's no longer a blocker. But for any of our applications, we've not noticed any kind of startup overhead. I know like initially with Lambda, that was a really big thing and people were really worried about it. If you have some super high latency thing and you're always going in and out, like high trading or something, maybe that would be a concern, and that's not the right fit. And you actually need something that's warm. Maybe that's a case where you use your own EC2 servers and you're not ready for serverless. Or maybe that's a case where you use ECS and you run your longer running processes that are handling web requests.
EC2, I know. What's ECS again?
This Elastic Container Service.
Okay, sorry, yeah.
It's like running containers. There's two ways to use this.
Oh,
ECS.
yes, the container service. Yes, I'm sorry. I actually, when it came to the container service, I've actually played more over in Azure when it comes to containers than I have with, because I actually, just like you see in other places, Azure came along, saw the mistakes that Amazon was making and built on them, and actually turned out something slightly better when it came to containers and Kubernetes, in my humble opinion. So, yeah. And like you mentioned here, Tim mentioned, was this, you pay them more money. We have the same thing. You want to, some of the stuff we do requires servers in EC2, but you want the high performance servers that imitate what we have inside our labs. Ooh, boy. Yeah. Money, money, money.
Yeah. Yeah. It's all trade-offs here, right? When we're trading off, like, these same discussions were had, these same arguments were had 10 years ago when it was like, maybe 15 years ago, when it's like, are you sure you want to go to the cloud? But what are those servers going to be like? You can't control them, and you don't know what kind of SSDs they're going to put in it. And we have our own special hardware needs. And it's like, my systems are so important, and we kind of didn't trust those cloud systems. And I feel like those same arguments are happening now, except for we're all talking about our cloud servers. And we're talking about, that Lambda, I don't know if it's fast enough.
Well, it's not now, but people have now have grown up with it literally, and basically understood that this is what I can do. Why do I need the headache of the hardware? Why do I need all this stuff? No, I thoroughly understand that. And to me, the bigger thing is less, the hardware is more about, I only need this resource for a short period of time, which I truly understand when I was testing WebSockets on there. And it's like, why do you want to buy a server to put on the internet? Well, you could just actually go spin this up, run it for a day and a half, and it goes away. And you save thousands of dollars at that point in time. And this is the same kind of thought down this path, just a different kind of thing. But you don't even control, not even the OS. You're above the OS. You're actually stepping above that.
Yeah. So the maps tell us, and computing history tells us, this stuff all keeps evolving. Right. Components tend to evolve towards commodity. And when we have commodity, then we have new innovation and new practices that build on top of those commodities.
I think that's your real selling point here, is that's really, this is what's going on. Yeah.
This is why I think like serverless is important. And it's not just like a buzzword that's coming out that's like, it's just going to be a fad. I don't see serverless as a fad. I see this as the direction things are going.
Well, the bottom line also is the code still matters. Somebody has to write the code to make it do the business process. And this is, what are you used to doing? Are you doing it this way? You test it out and you just put it out there. You don't care what the server it's on. You just upload it and it goes.
Yeah.
Same thing. It's the same thing.
I'm going to share two links. One is the introduction to Wardley Maps. Again, I love teaching Wardley Maps, so I'd be happy to you can get me to talk about that anytime. And then the other one is Simon has a really good presentation that uses maps to talk specifically about serverless, and I kind of stole some of that presentation for this presentation. So there's the link for that.
Now, so Luke, for you, our goal here is to teach engineering managers stuff. What do you think, as an engineering manager who doesn't know Wordly Maps, what would they learn from this about this? If you could explain that a little bit.
Yeah. So I think the value that I see from Wordly Maps are a way that we can draw something and then argue about it, or argue about we should do this versus that.
Okay.
And so I view maps just purely as a communication tool so that you and I can have a conversation. Like, let me come back to this slide here about, okay, you and I are starting a tea shop. And you've come to me and said, hey, Luke, we're going to do this tea shop. It's going to be great. One of our gimmicks is going to be these amazing custom-built kettles. And I think this is a really great idea. And like, we could draw a map, and I could be like, look, why are we buying custom-built kettles? That's crazy. They cost so much money. We got to order them from this country. They take so long to get here. This is something I could instead just draw a circle here. And we're going to buy, a commodity. A commodity thing. And we can have that argument to say, like, why does it make sense here or there? And what could we do with this versus that? So what we're trying to do in our company at Recollect is try to build some basic literacy about how to read maps, Wordly Maps, and so that we can use them kind of at the strategic level of our company. So our CEO can get up and be like, hey, this is what we're doing here, and here's a map, and here's our strategy. And so we can use that, and then someone can challenge that strategy. And so we're not just solely reliant on storytelling and whoever has the best narrative can win, but we can kind of talk and evaluate things. There's a whole ton of other really good things that come from mapping that you get around like deduplication in your infrastructure, understanding value and stuff like this.
Yeah, it's funny you would actually mention that, because one of the things that I keep reading about is in the Bay Area, there's the BART system. And the one problem they had is they decided to go with a non-standard wheelbase, which means all the cars have to be custom.
Yeah.
And it's really a problem for them to actually procure. They can't just go to some place and get something off the shelf. They always have to have a custom wheelbase. And it's costing them money. That decision cost them money. Did they use that chart? If they had a chart like that, figure out what would it be like to do something like that? So.
Yeah. It's really good. You can, Simon has some good slides here about how, you can basically start to look at, he's basically saying these are not maps. And a map basically has to have these elements. It has to be visual. It has to have context. It has to have a position. It has to have an anchor, like the north. And it has to have express movement on a map. So the one I was going to show, we're getting here. So this is how if you wanted to like map your own business, what you do is you start with a customer, you'd put your user needs. Maybe you have existing diagrams that look like this, right? You put your user needs at the top, and then you just build a chain of the needs of all of those things that those things depend on. And maps are just like real maps. You can have a map of the world, you can have a map of your city, you can have a map of your house. It's the same thing with Wordly Maps. You can map your competitive landscape, you can map just your product, you can map one component inside there. And so basically you've now got the position, which is relative to our anchor, which is the customer. And then we add the movement dimension, which is this evolution, right? So you've got, very novel things down to commodity hardware.
Yeah, wow.
And so this presentation that Simon has it goes into kind of how he came up with mapping, which is just looking around and seeing what other people did and not really seeing much in terms of strategy.
Okay.
It's kind of the same story I was telling here.
Okay. Thank you, Luke. That was exactly, I think that was a wonderful explanation. That was wonderful. Did a wonderful job on that.